This is part 2 of the regression videos. We have an example here. X is tree trunk circumferences in metres, and Y is the heights of those same trees in metres. And we could draw a scatter diagram. I'm not going to actually do that here. And then what we're aiming to work out now is the regression line, which is that best fit line. We're going to use the regression line Y on X. In the previous video we went through how we worked that out. We had a set of formulae. Step 1 was to work out the value of B, step 2 was to work out the value of A, step 3 was to get the equation itself. Now what we need is sigma x, sigma y, n, sigma x squared and sigma xy. All of those things we need. And you could work them out. You could put the values in your calculator, you could work them out, or often in a question they will be given to you. Because in an A-level question it does take a lot of time to work these things out. So for the example here, I'm going to tell you what some of these values are. Sigma x squared, sigma x, sigma xy, which is all the x values times by their y values and then added up, and sigma y, and we have here n being 6. So we will need to work out sxx and sxy. Let's do sxy first. That is sigma xy over n minus sigma x. Sorry, that over n shouldn't be there, it sits over here. Sigma xy minus sigma x, sigma y over n. So if you work that out first of all, sigma xy is the 28.447 number. Take away 3.87 times by 43.6 divided by 6. And if you work that out, that comes out to be 0.325. Then we would need to work out sigma sx, which is sigma x squared minus sigma x all squared over n. And again we can get these bits of information. That's 2.5275 minus 3.87 squared over 6. If you put that into a calculator, that one works out to be 0.03135. When we have those two things, step 1 was to work out the value of B, which is sxy over sxx. So that will be my 0.325 divided by my 0.03135. If you work out B, that's 10.37. Working up that list, the next thing I said we had to work out was A. A is y bar minus B x bar. A we don't know yet, but y, well that will be the sigma y over n. It's the average y value. And over here, x bar will be sigma x over n, the average x value. So I'm going to have 43.6 divided by 6 minus B, which I've just worked out as 10.37, times by 3.87 over 6. If you work that out, you get 0.58. Step 3 was y equals a plus bx. Now I know what my a is and I know what my b is, so I get y equals a plus bx. And that is the equation of your regression line. In other words, that is the equation of your best fit line. There's one thing that will always happen with these lines. This line, with this equation, is always guaranteed to go through the point x bar, y bar. It will always be guaranteed to go through that point. And if you had to draw that regression line on a diagram, say you already had your scatter diagram here with your 6 points on it, the best thing to do would just be to choose some x values Now in this example we're going from about 0.5 something up to about 0.8 something. So you might want to, for example, substitute x is 0.8 in here, and that will give you a y value. Maybe that will give you the y value there. Substitute 0.8 into there, that will give you a y value. Put that on there. Join it up with a straight line, and then as a check that the point x bar, y bar, and you worked out what x bar and y bar are earlier. Y bar was worked out there, x bar was worked out there. Check that actually that is somewhere on this line. If it is, you're okay. If it isn't, you know you've gone wrong somewhere, because it really should be there. The next video we'll talk a little bit about how we can use this line once we have it.